Welcome to Unit 10. In this unit, we will learn about different techniques for integration. So different ways to calculate integrals. So 10.1, integration using substitution. Example 1. We want to find the integral of 3x squared cosine x cubed dx. We're going to use the u substitution method. So what I notice here is that I have an x cubed inside the cosine. So I'm going to say that u equals x cubed. If u equals x cubed, then du over dx, the derivative is 3x squared. In other words, du must be equal to 3x squared dx. Okay. If that's the case, then we can calculate this integral. Because I'm just going to rearrange the cosine x cubed and 3x squared. Just write it in a different order to make it more clear. So I'm going to write the cosine x cubed first. Times 3x squared dx. But we see that 3x squared dx is just equal to du. That's just du. So that's why this integral must be equal to, and also u is x cubed. So x cubed is u, 3x squared dx is du. So I can change my variables. So cosine x cubed becomes cosine u. 3x squared dx becomes du. But that I know how to integrate. I know how to integrate cosine u. That's just sine u plus c. Let me write this more clearly. Sine u plus c. Okay. Now we just plug u equals x cubed back in. That's equal to sine of x cubed plus c. So that's the answer. So the integral of 3x squared cosine x cubed dx is sine of x cubed plus c. Okay. Now, what we're really doing here is the opposite of the chain rule. Why? If we're taking a derivative, if f is equal to sine x cubed plus c, then the derivative of f would be cosine x cubed times 3x squared. Okay. The derivative of c is just 0. And guess what? That's what we had started with. Cosine x cubed times 3x squared. 3x squared is the derivative of x cubed. So that's where we get it from the u substitution. Okay. Example 2. We want the integral of 5x to the 4th plus 6 over x to the 5th plus 6x dx. This time I'm going to let u equals x to the 5th power plus 6x. Then if that's the case, then du over dx would be 5x to the 4th power plus 6. In other words, du must be equal to 5x to the 4th power plus 6 times dx. Now we're ready to integrate. So my integral, 5x to the 4th plus 6 over x to the 5th plus 6x, well, the bottom is just u, because u is x to the 5th plus 6x. On top, we have 5x to the 4th plus 6 dx. That's equal to du. So this integral ends up just being the integral of du over u. To make that more clear, that's the same as 1 over u du And we know that's the integral of ln absolute value of u plus c. Now I can plug in my u. U is x squared plus 6x. So the answer is going to be ln of x squared plus 6x plus c. That's my integral. Okay. One more example. This time we have a definite integral, example 3. We're integrating sine of 2x dx from 0 to pi over 4. Okay. The first method is to just do the indefinite integral first. So we're gonna ignore the limits of integration. We'll just do this. We just want the integral of sine of 2x. Let me write this better. So we just want the integral of sine of 2x times dx. Okay, well u equals 2x, so du is equal to 2 dx, because du over dx is 2. That means that du over dx, du over dx is 2. Therefore, du is equal to 2 dx. Okay. The next part is for method 2, we can ignore that. So we know that du is 2 dx. Well, if du is equal to 2 dx, actually let me write this here. Du equals 2 dx. That means that du over 2 is equal to dx. Therefore, this term dx turns into du over 2. Okay. And that means that my integral, the integral of sine 2x times dx, is the integral has to equal sine u times du over 2. That's the same as 1/2 times the integral of sine u du. That's negative 1/2 times cosine u plus c. Now I don't care about the plus c here, because we're going to have a definite integral. We'll be plugging things in. So that has to equal negative 1/2 of cosine of 2x. Okay. So now we plug in. We know that we're evaluating our integral from 0 to pi over 4. Okay. So that's going to equal to negative 1/2 of cosine of pi over 4 times 2, because 2x, minus cosine of 0, which is equal to negative 1/2 of cosine of pi over 2 minus cosine 0. That's equal to negative 1/2 of 0 minus 1, which gives us positive 1/2. That's it. Okay. In your notes, I have this typed out in LaTeX, so it's going to be a lot more clear. You can read this. Okay. That's one way of doing it. Just do the indefinite integral and then plug in the limits. I think that's the easier way. Another way you can do this is, if we change it to u, I can also change the limits that we're integrating. So if we use the second method, then we're going to end up with sine u times du over 2, just like the first method from here. But we got to figure out what numbers goes in here and here, what we're integrating from. It's not going to be 0 to pi over 4. Instead, when x equals 0, u equals 0, because u is 2x. When x is pi over 4, u must be pi over 2, because u is 2x. So we're integrating sine of u times du over 2, but we're integrating from 0 to pi over 2. Okay. Same integral, I get negative 1/2 cosine u. But I'm integrating from 0 to pi over 2. The 0 and pi over 2 came from here. If x is 0, u is 0. X is pi over 4, u is pi over 2. So this again gives us negative 1/2 times cosine of pi over 2 minus cosine 0, which gives us the same answer, 1/2. Okay? That's it.